The transpose of some matrix A is obtained by interchanging the rows and columns of A. So if we look at this at the matrix entry level, we have the entry in A at row I and column J, and the entry in row I and column J of the transpose is equal to the entry in matrix A at row J and column I. So for example, if we take the transpose of this matrix A, we basically interchange the rows with the columns. So the first row becomes the first column, and the second row becomes the second column. So for example, the entry in a transpose of A in row 2 column 1 should be equal to the entry in A in row 1 and column 2. Now for the special case of a square matrix, if we take the transpose of B, then the elements on the main diagonal remain the same. So for our square matrix here, all we do is swap the symmetric elements above and below the diagonal, according to our equation here for the transpose. So the element in row 1 column 2 is swapped with the element in row 2 column 1. And the element in row 1 column 3 is swapped with the element in row 3 column 1. And 2, 3 is swapped with 3, 2. And the transpose of our matrix C with a single row, which is a row vector, becomes a column vector. So we have the entry in row 1 column 1 being the same, and the entry in row 1 column 2 becomes the entry in row 2 column 1 in our transpose. And the entry in row 1 column 3 becomes the entry in row 3 column 1 in the transpose.